Our next speaker is going to be Whitney Taylor from PEO Subs, and Whitney's been there about 4 years now, and as the SBIR director for Team Submarine, and they do subs as well as a lot of the combat systems and different components that go on them. With the Virginia class program and Ohio replacement program, he has a pretty good budget, and so therefore the SBIR program has a pretty good budget. So, Whitney?
Thank you very much. Morning, everybody. As introduced, I'm Whitney Taylor, Technology Manager for PEO Subs. So I'll go straight into it. My first topic is primarily for the Virginia class, but Virginia and Ohio class, the Ohio replacement class, are pretty much going to be as close to each other as feasible. So everything that Virginia has or does, Ohio will pretty much follow. Ohio replacement will pretty much follow suit. The first topic is for submarine shipboard power supply. Both these topics are related, obviously, because the pictures are pretty close. But so one of a big problem in submarines is power supply. They get power surges, things go down. So they're trying to create more clean power. So to develop a high power, short duration, uninterruptible power supply compatible with electronic systems on submarines and their bus transfers. The next topic, very similar, is for power unbalanced correction. Due to shifting kind of requirements and obsolescence, the batteries or the power supplies submit inner power not in different arrangements than what's required for the electrical systems. So if it's supposed to receive a signal or energy in 30 seconds, it gets it in 40 seconds, and then it cuts out, and this causes for different systems to go down for random reasons. So those topics were for PMS 450, Virginia class. The next topic is from PMS 485. They're a maritime surveillance program office out in San Diego. They work a lot with SPAWAR. This topic is for broadband sonar for undersea marine life and hazard detection. So specifically, they already have, or commercially, they have something called Fish Finder, which allows you to identify, or fishermen to come out and identify when they have fish or whatnot. So what they're looking for is to take that type of technology and move it to actually tell you specifically what type of marine life is coming. So when you have divers down there, you know, and you don't want them to be diving if you have sharks or marine life that's hazardous to humans. Also, if you have sea turtles. So it's to classify, specifically it's to classify the different type of sea life. So like I said, they already have Fish Finder, which is what they use. They're looking for more of an algorithm to go into already existing COTS. So that was, this topic was developed by Don Ringel. The next topic, this is still with PMS 485, is the towed array straightness for 3 dimensions. So the towed array is physically connected to the submarine and drags along, and the wire always gets caught or tangled just due to hydrodynamics. So they're looking for a way to keep the line from becoming tangled as so that it doesn't drag along the sea and that the wire and connections don't get damaged. The next topic is from PMS 397. This is the Ohio Replacement Program Office for the next generation submarines. This topic is for Biologic Sonar and Processing Network to improve situational awareness. Basically, in short, dolphins do sonar better than our current technology. So they want to develop an algorithm that more mimics how bats and dolphins and animals use sonar and interpret what's going forward. The next topic is still with 397, probably my favorite topic, the deep fat fryer replacement. Essentially what they're looking for is oilless or minimal frying oil when cooking. They want to be able to, the boomers, or what will be the future boomers, they're pretty big, their crew complements are large, and they have requirements with which to cook and feed the crew in a certain amount of time. So based on the current design, which is offered the Virginia class, they want to basically use the same fryer that they have now in size and dimensions, but with less grease. And just for specifics, they would like to be able to make French fried potatoes, chicken fried steak, chicken cordon bleu, fried shrimp, fried chicken, home fried potatoes, fried fish portions, fried catfish, and fried okra. The next topic is also with 397. The topic author was Dr. Grizzo, who actually is now my colleague and the technology manager for LCS. So I will get you the actual topic author. I believe when it was published, like what's out for that you can review has the actual topic author, but I can get you that contact information. This is for damage visualization of submarine Navy composites. With the dawn of or advent of additive manufacturing, we're going to be using more composite materials. So we want to be able to detect damage, on like the surface and also within it. So it's to come up with different methods to visually assess whether it's been damaged or not. The next topic is from PMS 435. That's our electronic warfare and imaging program office. They're looking for a random anti-reflective hydrophobic texture on semi-hypospheric domes. This will be going into the mass of the submarines to help with their imaging and to prevent sun glint. The next topic is biometric atmospheric modeling and point measurements from a single profile. This is our only STTR, so you would have to pair up with an academic institution if you choose to work on this. It's essentially from the submarine, detect change in atmospheric pressure in different weather systems. Different sea states and weather systems may make you more vulnerable to electronic attack, or not attack. The electromagnetic spectrum, you may be more vulnerable to detection given different sea states and weather anomalies. So it's to detect where those are in advance so they can know where they should position the submarine. The next topic, still with PMS 435, is the solid state radar emitter identification. This is to take an existing technology and apply it to submarines and modify it, as militarize it as necessary, and develop algorithms to detect, classify, and uniquely identify solid state in real time. The next topic comes from PMS 425. That's our combat and weapon systems program. This is for dual authentication for Navy tactical systems. As we come into cybersecurity, they would like to have easy, fast, dual authentication of who the person is, so that when you're going into a system, you don't have to use your CAT card and enter in your password at different times. It can be biometrics, it can be something, but it's just, you want to be able to seamlessly access the system and accurately identify that the right person with the right authorities is accessing it. The next topic is from PMS 401. There are acoustics and towed arrays program. This is an innovative capstan rim friction coating. So this is that wire that was going to, in the previous topic, that you didn't want to get tangled with PMS 485. This is a coating that will reduce the friction on the capstan that retracts it and extends it. The next topic is the best practices in finite element modeling of complex structures. So with PMS 397, as they're developing the next generation of submarines, and PMS 450 continues to build and design the next versions of the Virginia class, our technical warrant holders and engineering directorate have been requiring them to have 3D models before they sign off and start to concur as the designs. So this will be to accurately come up with a system to easily, a toolkit basically, to make 3D designs of concepts for the future. The next topic goes back to 450, and that's the laser module assembly. So this is the lightweight aperture laser. It's a fiber optic laser that identifies acoustic contacts. So right now, I believe this is at 1330 nanometers of wavelength, and I believe the commercial industry standard is 1550 nanometers. So all the ones that are currently, and they stopped making them, so all the ones that are currently in submarines are obsolete, or they will be obsolete. They are obsolete now, and they can't buy anymore, they can't procure anymore. So the stockpile that the Navy has is it, and we need to, in a cost-effective means, find out a way to increase the wavelength, but keep it in the standard form and fit of the current laser. My next two topics are with CO73. They're the Undersea Technology Directorate, the program, my home code actually. This is for a sub-safe hull penetrator for submarine high energy laser. The sub-safe program has different requirements as for their boundaries and whatnot. And essentially with the heat and energy requirements needed to have the laser, I want you to take a look and try and make it within the confines and requirements that make it sub-safe. I can go into submarine safety at a different time or outside of this meeting if you like to. And the last, my last topic is the sub-safe compliant external sensors. Right now, a lot of our external sensors go out of the torpedo tube, and well, it's kind of bad to leave that open for an extended amount of time. So as they have these, whatever, be it a vehicle or a sensor, whatever they have out there outside of the torpedo tube, they're looking for a way to still communicate it with it and receive information, but closing the hatch, be it some really super thin cord or connector, or even something wireless. That's where the innovation comes in. So those are all of the PEO Subs topics. Thank you very much. If you have any questions, please feel free to come see me during lunch or at the end of the matchmaking sessions. Thank you.
Thank you, Rich. Yeah. Thank you, Whitney. The deep fat fish fryer was always a contentious issue. I know in the early Virginia days, we had to evaluate using meals ready to eat, like the MREs. And we were going to have a revolt with all the chiefs in the office at the time, as well as the COs. But that does place a big burden on firefighting on board. So it's an expensive item, but boy, it sure keeps the crew happy.